Hey guys, welcome to day 13. This is significant figures continued. So last time we met, I kind of explained how we determine a significant figure, and we said zeros can be tricky sometimes. So examples of when zeros are significant is if they are sandwiched in between. So like in 409, the zero is sandwiched in between two non-zero digits. So we have three significant figures. Another example of when a zero is significant is if it is a final zero after the decimal. So the two examples here have a zero that's after the decimal. I say that it's a twice right rule. So 5.0 would have two sig figs, and 0.0040230 starting with the 4 would have 5 sig figs. Now, examples of when a 0 is not a sig fig can be a little bit tricky. So leftmost zeros in front of non-zero digits are not significant. So for this example, 0.021, we only have 2 sig figs. Or placeholder zeros that are to the left of an understood decimal, like the 0 in 970. So the 9 and the 7 are significant, but the 0 is not. All right, so we've reviewed when zeros are significant. Let's focus a little bit on rounding. Okay, now rounding comes into play when we start to multiply and divide using sig figs, but for now, you know the basic rules for rounding. If a number is followed by a 0, 1, 2, 3, 4, you just kind of drop that final digit. If a number is followed by a 5, 6, 7, 8, 9, you round up to the next highest digit. So let's do this with pi. So for my first example, I want to round to 5 significant digits. So starting from left to right, I'm going to count 1, 2, 3, 4, 5 positions. Now, the 9 is following the 5. So what we're going to do is we're going to drop the 9, but we have to decide what are we going to do to the 5. Are we going to keep the 5 or are we going to round it up? In the case of our first example, if a 5 is followed by a 9, we will round it up. So if we wanted to round this number to 5 sig figs, if a 5 is followed by a 9, it rounds up to a 6. So 5 sig figs would be that example. All right, so let's do the same thing, except this time, let's round to 4 sig figs. So starting from left to right, starting with a 3, I counted basically 4 digits over. Now, the last digit that we're allowed to keep is the 1, and the 1 is followed by a 5. So the rules say that if a number is followed by a 5, 6, 7, 8, 9, we can round up. So I'm going to call this 3.14, and my fourth digit will be a 1 rounded up to a 2 because it's followed by a 5. All right, next example, 3 sig figs. All right, let's erase over here. So starting from left to right, I count out 3 digits. And then I look at the digit immediately to the right of the final digit that I can keep. And I can keep the 3, I can keep the 0.14, and the final 4 is followed by a 1. So in this case, I'm just going to drop, and I'm going to call it 3.14. All right, let's do another example here. Let's do it to 2 sig figs. So I can keep the 3, I can keep the 1. If a 1 is followed by a 4, we can just drop the 4. And for my final example, if I wanted to round it to 1 sig fig, I would just call this 3. So what we did is we just rounded pi to 5 sig figs, 4 sig figs, 3, 2, and 1 sig figs. All right, you guys are going to have to do that in your homework. Always start from left. Find the first leftmost significant figure and then count digits. And then what is that digit immediately following that final digit? And that's going to determine. So a 0 through 4, you can just drop. If a number is followed by a 5 through 9, a 5 through 9, you can round up. I'll just say you can raise it by 1. All right. Now, the next thing I want to talk about is measurements, and I think the best way I can do this is just by showing you some measurements. So for my first example, it's a graduate cylinder. And one thing you should know about a graduated cylinder is that you should always read it from the center of the meniscus. So the center of the meniscus is going to be here. And if I kind of put a little dot right there, that is going to be a representation of where. So what I'm not going to do is I'm not going to take the readings from the side of the cylinder. That's just not best practice. So what I want to do is I want to see how many divisions are there between 40 and 50. There are 10 divisions. So that tells me that each one of those divisions is 1 ml. Now, I want to round this measurement to the first digit beyond it. So I can call it, let's see, this is going to be 42. This number is going to be 43. And this number is going to be 44. So our graduate cylinder goes to the nearest 1 ml, which means that we need to estimate one digit beyond the 1 ml. And if we're doing that, that would be to the 10th of an ml. So we're not going to call it 42, okay? Even though it's very close to 42, it's still a little bit above 42. We're not going to call it 43. Even though it's very, very close to 43, we can't call it 43. Now, what we could do is we could call it 43 point something. Now, if you think that that measurement falls exactly on 43, we're not going to call it 43. We're going to call it 43.0. So this is our estimated digit. Now you may think that that line is slightly below 43. So maybe you want to call it 42.9. That is also an acceptable response. Or you may think that that number is ever so slightly above 43. You could call it 43.1. Point being, your graduate cylinder goes to the nearest 1 ml. You have to estimate one digit beyond that, which would be to the nearest 10th of an ml. So that's what we mean by the first degree of uncertainty, or the last digit is estimated. So if your scale goes to the nearest 1, you estimate to the nearest 10th. All right, next example. We don't really use triple beam balances anymore, but if you did, what you're going to do is you're basically going to take these measurements and you're going to add them up. So 350, and we can all agree that it's somewhere between 4 and 5. So if we add those up, we're going to get 354. Now, if we zoom in just a little bit, we actually want to read it from this point right there. And if you look, 4 and 5 is divided into 10 increments. That means that this triple beam balance is accurate to the 10th of a gram. So we're not going to go to the 10th of a gram, we are going to go to the 100th of a gram. If I erase my little line there, I think it's really close to 4.6. Now, if you think that it's exactly 4.6, you're going to call it 354.60. But some of you may disagree. Some of you may think that it is slightly, some of you may think that it's slightly above the 0.6. So you could call it 354 point, maybe you could call it 0.61. Some of you might think that that reading is slightly below the 0.6. So maybe you can call it 354 point, and if we had to estimate a little bit low, 0.59. Point being, the triple beam balance goes to the nearest 10th of a gram, and you have to estimate to the 100th of a gram. I think all three of these answers would be acceptable responses. All right, one last example. Oops, my ruler didn't turn out very good. So what I'm going to do is I'm going to give you one more real quick example in the notes, and I will catch up with you guys tomorrow. Just remember, if your centimeter scale goes to the 10th of a gram, you have to go to the 100th. If your digital balance goes to the nearest gram, you have to estimate to the nearest 10th. So guys, just make sure you're estimating your measurements. Always estimate one digit beyond what the instrument recommends. And I love you guys. I miss you guys. I'll talk to you tomorrow.